So question 3 of the high-speed trains practice situational problem is asking you to figure out, it says if you look at the end here once you read this problem, SuperTrain has a fixed cost of $2 billion for the necessary infrastructure. SuperTrain is one of the 4 types of trains that you saw at the beginning of the problem. As it even tells you, as you saw in the table on the first page. However, the other trains have infrastructure costs that depend on the length of the track that must be completed. The SuperTrain, it tells you it's $2 billion no matter how long the track is. But these other ones, it depends on the length of the track. And you'll see why when we look at the table. What you're going to have to do is use your answer from part 2, which was just telling you how long the train line was going to be. We got 128 kilometers for that, to figure out the total cost. So if you look at the table, you see why this makes sense. This table here, the express train has an infrastructure cost that's by the meter, $10,000 for every meter. Pretty pricey. The turbo train costs you $2.5 million for every kilometer. The Rapido costs $25 million per kilometer. And the super train, like you just read in the problem, that's $2 billion. That's not depending on how long it is. That's just a flat $2 billion. So the question is saying, figure out if we're dealing with a 128 kilometer track, like we saw in part 2, how much is each of these going to cost? Now, an important little point for you guys. When you have a question in a situational problem that depends on an answer from another part, often what will happen is somebody will get further down, they get down to question 5 or 6, then they'll realize, oh, the information I was using back in part 2 is wrong. So I've been building on all this wrong information, and then they'll go and they'll start erasing everything, and then the bell will go and they'll hand in a blank situational problem. Don't do this. If you realize you've made a mistake, then just keep going. All right. The math, the thinking that you're doing on those other questions should be consequent with whatever answer you happen to come up with part 2. Okay, if you got, that this was 1,200 kilometers, but all the math you did here is consistent with being 1,200 kilometers, I'm going to recognize that. I'm going to be able to give you a large part of the marks. Okay, so don't erase everything and then hand it and end up, when you're trying to correct everything, losing all kinds of time. I see this happen all the time. It's never a good strategy. All right. So let's get to the problem. We haven't even started it yet. I've been blathering on here. If I know that it's 128 kilometers between one destination and the other, what's the total cost for these 3 other trains? Okay, so first thing I know that for the express train, it costs $10,000 per meter. This is probably going to be the hardest one to do, so let me do these other ones first so you can see how it works. I have $2.5 million per kilometer for the turbo train. Again, I've said this for other problems, but it's a good strategy to remind yourself that $2.5 million per kilometer is a fraction. Let me write it that way so I can remind myself what I'm dealing with. $2.5 million. Let me put some zeros in there so it's easier for you to see that I'm talking about millions. $2.5 million. Let me put units on there for 1 kilometer. It's a fraction, just like that. And if it's 2,500,000 for 1 kilometer, I'm trying to find out the cost for 128 kilometers. So really all this problem is asking me to do is to set up a proportion that's got a missing term in it. That just means I have 3 parts of a proportion. Again, in case you forgot, a proportion is an equality. That means you got an equal sign between 2 equivalent rates or ratios. Here I have 1 rate, that's 2.5 million for 1 kilometer, and I'm going to make an equivalent rate that's, instead of making it for 1 kilometer, that's for 128 kilometers. If you set this up properly, then figuring out that missing amount of money becomes second nature to you, because it's just, you could use the fish method. You could say, well, I'm doing 1 times 128 down here, so let me do this times 128 to find out what goes here. Either of those ways, perfectly good for getting your answer. The toughest part is just setting up the numbers in the right way like we have here. So how do you do that? You say to yourself, this was just me rewriting the information, that 2.5 million per kilometer, as a fraction. Since proportions are dealing with equivalent fractions, equivalent rates, equivalent ratios, turning one of these into a fraction is making my life easier already. On the other side, I say to myself, okay, what numbers do I know that are missing? Kilometers, do I know kilometers? Yes, I know that it's 128 kilometers. Do I know the money? No. So I'm not going to be writing 128 up there, that the final cost is $128 or anything like that. My 128 is going to go in the kilometer place, lining up where with the other kilometers are. Now that I've set it up, figuring out is easy. I just say to myself, this times 128 gets me here, so I should do the same thing on the top. And I have to figure out 2.5 million times 128. And there's a bunch of ways you can do this. If you're allowed a calculator, then it's super easy. If you're not allowed a calculator, then don't worry. You just follow your usual rules for multiplication. You do 2.5 million times 8. Let me make a little more space here to make this easier to do. Right? This is stuff that you had to do back in elementary school. You would say, okay, let me do, this is kind of hard to do backwards, isn't it? 0, and then 0, and 0. This is me just multiplying 0 times 8, 0 times 8, 0 times 8, 0 times 8, another 0 times 8, another 0 times 8. And then finally 5 times 8 gives me 40, so I put 0 down there. I carry a 4, which is kind of hard for me to write here. 2 times 8 is 16, so that gives me 20. So just like that, I've got my first row here, which is 20 million. Then I say, okay, my next row, I got to build in a 0 there, like that. And then I would be typing in across like this. So 2,500,000 times 2 is going to give me a clean 5 million. It's just easier for me to write 5 million like that because this doesn't work the way paper works, as I'm sure you can guess. I hope you can forgive me for this one, guys. So I've got 5 million when I do 2,500,000 times 2. And then when I do 2,500,000 times 1, I end up with 2,500,000. That's the easy one. And I want to make sure that my zeros line up like they should. Then I add all these up. I have, at the very end, I have 0, 0, 0, 0, 0, 0, 0, and then 12. So let me put a 2 there for you. All these other zeros are just following. 12, and then I put a 1 up on top. 1 plus 2 gives me 3. So I end up with this very large number as being the, that was meant to be a dollar sign. This ends up being my cost for whichever train this was, the turbo train, $32 million. Now, if you look here, if you're quick, you'll notice that, well, this and this is just an extra 0 per kilometer. So the total cost for the Rapido train is going to be not $320 million for 128 kilometers. It's going to be $3.2 billion for 128 kilometers. It's just going to be the same number here with another 0 on it. So I'm going to be a little bit lazy because I think you understand the explanation here, and the answer is just going to have another 0 on it. And again, this guy is my, what is this, Rapido? Yes, Rapido. And up here, this was the, I think it was the turbo train. Okay. Now I mentioned that the hardest one is going to be this guy here, the Express, just because there's a little bit more work to do. It's $10,000 per meter. So let me write this out. $10,000, again, remind myself, $10,000 per 1 meter. I'm just reminding myself that I can turn this into a fraction. And then I say I've got to get an equivalent fraction that will be for 128 kilometers. So how can I do this? There's a bunch of ways. One is I could just set up my proportion the way I had with the previous ones. I know I should have my distances on the bottom, like this. And then I know that I have to figure out what's on top. But if you're going to be doing proportions, it's much safer to get everything that's on the same, like everything on the bottom here should be in the same units. So I should turn this into meters before I start doing anything like fish method or cross multiplication. 128 kilometers, if I turn that into meters, I can use my mnemonic device, King Henry died, mother didn't care much, whichever one you prefer, and realize that to go from kilometers to meters, I just have to add 3 zeros. So in this case here, I'm going to get rid of the, well, this is a very fine eraser. Luckily, you guys have much better fine motor control than I do, so you'll be able to do a better job on the paper there. But I need to add 3 zeros here, and suddenly my 128 kilometers is now 128,000 meters. And this way I can figure out how much it will cost. I just do 128,000 times 10,000 divided by 1. So 128,000 times 10,000, that just means adding 4 zeros. So I've got 128,000, and then I just add 4 zeros. I'm going to fix up my spacing here. And this is what I end up with as a cost for that one. So $1.28 billion. Very expensive. And that is your cost for the express train. Now, always good in a situation problem to make sure you know what question is that you're supposed to be answering. This was question 3. It was saying, just determine the total cost of the infrastructure. It's not asking me to put them in order from cheapest to most expensive or most expensive to cheapest. I just had to figure out that the Rapido train costs, what is this, $3.2 billion. The turbo train is, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 320 million. And the express train is 1.28 billion. So turbo train is actually a nice little bargain here at $320 million, a little spare change that it would cost you. And that's how you do question 3.